Fluvial processes and landforms. Objectives. After attending this module, the user would be able to comprehend about the geomorphic processes promoted on the surface of the earth by running water and streams as geological agents. This module also highlights all the landforms created by the fluvial processes, including the erosional, transportational, and depositional landforms. The role of streams, drainage networks, and the stages of development of streams are also explained. Introduction. Rivers and running water are dynamic geomorphic agents. Flow of water has a force, velocity, and power to generate power. There are many natural and dynamic processes happening along a river. When there are circumstances, there may be severe floods along the river courses, which can destroy everything along the flow path. Natural hazards are also caused by streams. Flowing water has the ability to dissolve the soluble mineral substances available on its way. The processes enacted by streams are called as fluvial processes. The word fluvius is derived from the Latin word meaning river. The word fluvial is used to denote the running water as streams or rivers. Fluvial processes entail the erosion, transportation, and deposition of earth materials by running water. Fluvial processes and fluvial landforms dominate land surfaces the world over, as opposed to the limited effects of glacial, coastal, and wind processes. Streams and drainages. Streams are flowing water bodies. The flow of water originates after every rain. Rainwater falling on all the slopes of a land gets collected and start flowing on the land as overland flow. They merge together along the converging slopes, join together, and run as a main stream. The main stream normally contains the cumulative volume of flow. The total water will be flowing out through a single outlet called as river mouth. The entire area encompassing the catchment zone up to the river mouth, controlling this cumulative flow, is known as a river basin. It is also called as a drainage basin. Stream valleys. Every stream has its own valley. Valleys are common on the earth's surface. A valley is a depression on the earth's surface drained by and whose form is changed by water under the attractive force of gravity between two adjacent uplands. Every valley has its own length and slope. The horizontal distance measured in the cross-section in a linear depression between two adjacent uplands is known as its length. The slope of a valley for a given reach refers to the difference in elevation between the upstream end to a point of reach along the downstream side. Valley development. Valley development is a unique hydraulic process. It happens due to three concomitant processes as valley deepening, valley widening, and valley lengthening. Valley deepening. Valley deepening is effected by hydraulic action, corrosion or abrasion of the floor of the valley, pothole drilling along the valley floor and at the base of waterfalls, corrosion, weathering of the stream bed. Valley widening. Valley widening is accomplished by lateral erosion or planation by the stream in a valley, hydraulic action, corrosion, rainwash and sheet wash, gullying on valley sides, weathering and mass wasting, role of incoming tributaries. Valley lengthening. Valley lengthening may take place due to three ways as extension by headward erosion, increase in size of their meanders, extension at the confluence due to subsidence. The maximum downward limit for valley deepening is known as base level of erosion. In some cases, the channel length may increase due to a meandering course of a river, but the valley length is short. Stages of a river. A river is said to be starting from a youthful stage, run through a mature stage, and reaches its old stage depending upon its age, length of flow path, density of streams, population of its streams, discharge volumes, and width of its mouth. Youthful stage. A youthful stream is one that is undergoing initial development. Consequently, it has a steep, irregular gradient, few tributaries or meanders, and a narrow floodplain. In addition, most of the erosion takes place in a downward direction. Youthful rivers are typically found in the highland or mountainous areas. They are characterized by steep slopes. They show a relatively small volume of water and rapid flow. Youthful streams may extend their source or head into higher elevation by cutting channels backward or upslope. Because their rapid flow leads to rapid erosion, youthful rivers tend to have narrow V-shaped valleys that are relatively straight. Mature stage. A mature stage river possesses a gentler slope and a flatter land surface. Mature rivers tend to have many well-developed branches, streams called as tributary. The river is characterized by a broad, flat river valley with a well-developed floodplain. The river channel will be relatively broad because the river, having reached a lower elevation and lost its steep slope, works on eroding the sides of the channel. They show a gently meandering course over the floodplain regions. A mature stage river normally reaches a stage of equilibrium in which its erosion and deposition are nearly in balance. Such rivers move a huge amount of water in their courses. Power of the river. As time progresses and erosion continues, the stream gradient decreases. The number of course deflections, on the other hand, increases so that meanders begin to form. Eventually, the degree of lateral erosion becomes equivalent to that of downward erosion. This intermediate stage of development is referred to as maturity. Old stage. During the old stage, the relief around the river becomes extremely flat. The river will have almost no slope and consequently very little momentum or speed. These are characterized by very elaborate and intricately meandering river courses. They show swampy areas around the old rivers because the lack of slope leads to very poor drainage. The old rivers are very muddy. This is due to the consequence of large amounts of suspended material being carried by the river with low velocity. The river at this stage will show a high discharge of water. The final stage of stream evolution occurs when lateral erosion takes precedence over downcutting. These so-called old age streams have very low gradient and wide floodplains. Profiles of a stream. Every stream has its longitudinal profile and lateral cross sections. The longitudinal profile of a stream is analyzed to know the water surface slope. It helps to compute the velocity of flow and the gradient. The longitudinal profile of a river shows how a river's gradient changes as it flows from its source to its mouth. The long profile shows how, in the upper stage of a river's course, the river's gradient is steep, but it gradually flattens out as the river erodes towards its base level. These are points where the gradient of the river changes suddenly, and can be caused by landforms like waterfalls or lakes, where the lithology of the river changes and differential erosion takes place. A river's course. The course a river takes is split into 3 stages: the upper, middle, and lower stage. In the upper stage, the river is close to its source and high above its base level. In the upper course, the gradient of the river is steep and the river is high above sea level, giving it a large amount of gravitational potential energy that can be converted to kinetic energy later on. In the middle course, the river's gravitational potential energy gets converted to kinetic energy, and the gradient begins to level out, resulting in the river's velocity increasing. By the time the river reaches its lower stage, it has next to no gravitational potential energy, but lots of kinetic energy, resulting in a high velocity. In the lower stage, the river will be far away from its source, close to the mouth, and not far above its base level. In the middle stage, it's somewhere in between. The total energy that a river possesses varies from one stage to another. It is because of changes in the river's height, gradient, and speed. Processes in the upper course. In the upper course, the river has a lot of gravitational potential energy. Hence, it has a lot of energy to erode vertically. The bed of the river is eroded greatly, while the banks aren't eroded as much. The river at this stage mainly transports large pieces of angular rocks. This increases erosion processes. Vertical erosion is further increased by the rough nature of the channel in the upper course, which increases the water's turbulence and its ability to erode. Erosion and transportation takes place in large quantities in the upper course when the river's discharge is high after periods of heavy precipitation. When the river's discharge falls, the river stops transporting the large boulders and deposits them. Processes in the middle course. In the middle course, the river has a less gravitational potential energy but possesses more kinetic energy. Due to this, the erosion shifts from vertical to lateral erosion. Corrosion is still the main erosive process as large particles are transported by saltation. The average load size has decreased in the middle course, so more load is being transported in suspension. In the middle course, the river can induce floods. There is also a possibility that the river may deposit its gravel and sand-sized particles onto its floodplain in this stage. Processes in the lower course. In the lower course, the river will have no gravitational potential energy. Hence, the erosion is almost exclusively lateral. There isn't much of erosion as the channel is smoother, resulting in less turbulent flow. The main place where erosion takes place is where the river meanders. The average particle size is very small. The river's sediment load is mainly composed of silts and clays. These are transported in suspension or even in solution. Similar to the middle course, when there is flooding in the river, it deposits all its load. Here, the deposition takes place at the mouth of the river, where the river meets the sea or a lake. Erosional work of streams. Moving water erodes all Earth's surface materials, not only along the bed, but also along the sides of the channel. The river transports all the eroded materials onto a new location and then deposits them. The materials deposited by streams are called as alluvium. The ability of a stream to do all these works is a function of stream velocity and discharge. Running water is capable of conducting headward erosion, vertical erosion, and lateral erosion. A three-way mechanism. Flowing water erodes in 3 ways. Firstly, the flowing water dissolves the soluble materials from the channel and contributes to the stream's dissolved load or solution load. Secondly, the impact of water or hydraulic action on the sides and bed of the channel try to dislodge the materials and makes them available for transport as a part of the stream load. Thirdly, the materials that are too heavy to carry in suspension scoot and roll across the bed and eroding the channel by abrasion. Rate of erosion. The rate of erosion depends on many factors. Climatic factors include the amount and intensity of precipitation, the average temperature, as well as the typical temperature range and seasonality, the wind speed, and finally the storm frequency. The erosion will continue till the base level is reached. The base level is the lowest elevation point to which a stream can flow and cut down. It is the ultimate level which is the maximum, and that is the sea level. The geological and biological factors. The geologic factors include the sediment or rock type, its porosity and permeability, the slope or gradient of the land, and nature of structures like tilts, faults, folds, or weathered. The biological factors include ground cover by vegetation or lack thereof, the type of organisms inhabiting the area, and the land use. Sediments consisting of more clay fractions tend to erode less than those with sand or silt fractions. Types of erosion. Types of erosion carried out by running water are the following: splash erosion, sheet erosion, rill erosion, gully erosion, stream erosion, bank erosion. Splash erosion. Splash erosion is the first stage of the erosion process. Splash erosion is the detachment and airborne movement of small soil particles caused by the impact of raindrops on soil. Splash erosion occurs when raindrops hit the bare soils. The explosive impact breaks up the soil aggregates so that all the individual soil particles are splashed onto the soil surface. The splashed particles can rise as high as 60 centimeters above the ground and move up to 1.5 meters from the point of impact. The particles block the spaces between soil aggregates so that the soil forms a crust that reduces the infiltration rate and increases the runoff. Sheet erosion. Sheet erosion is the detachment of soil particles by raindrop impact and their removal downslope by water flowing overland as a sheet instead of in definite channels or rills. The impact of the raindrop breaks apart the soil aggregate. Particles of clay, silt, and sand fill the soil pores and reduce infiltration. After the surface pores are filled with sand, silt, or clay, overland flow of water begins due to the lowering of infiltration rates. Once the rate of falling rain is faster than infiltration, runoff takes place. There are two stages of sheet erosion. The first is rain splash, in which soil particles are knocked into the air by raindrop impact. In the second stage, the loose particles are moved downslope by broad sheets of rapidly flowing water filled with sediment known as sheet floods. This stage of sheet erosion is generally produced by cloudbursts. The sheet floods commonly travel for short distances and may last only for a short period of time. These are very different hydraulic environments. Eroding rills evolve morphologically with reference to both time and space. The rill bed surface changes as soil erodes, which in turn alters the hydraulics of the flow. The hydraulics of flow is the driving mechanism for the erosion process. The process of rill evolution involves a feedback loop between flow detachment, hydraulics, and the bed form. The factors involved in rill erosion are flow velocity, depth, width, hydraulic roughness, local bed slope, friction slope, and detachment rate. Gully erosion. Gully erosion is another type of erosion. It is also called as ephemeral gully erosion. It occurs when water flows in narrow channels during or immediately after heavy rains or melting of snow in mountainous regions. A gully is sufficiently deep that it would not be routinely destroyed by any tillage operations. The narrow channels or gullies may be of considerable depth, ranging from 0.3 to 0.6 meters to as much as 25 to 30 meters. Stream erosion. It is the valley or stream erosion which creates a lot of landforms. The valley or stream erosion occurs with continued water flow along a linear surface. The erosion is both downward and headward. The downward action will be deepening the valley, and the headward erosion will be extending the valley into the hillside. In the earliest stage of stream erosion, the erosive activity is dominantly vertical. During this stage, the valleys will have a typical V-shaped cross-section and the stream gradient is relatively steep. When some base level is reached, the erosive activity switches to lateral erosion, which widens the valley floor and creates a narrow floodplain. The stream gradient becomes nearly flat, and lateral deposition of sediments becomes important as the stream meanders across the valley floor. The natural process of riverbank erosion can produce favorable outcomes, such as the formation of productive floodplains and alluvial terraces. The major causes of bank erosion are flooding, land use, stream management, overclearing of catchment and stream bank vegetation, and poorly managed sand and gravel extraction. Transportation work of streams. Once the surface material is detached from the source by the water, it can be transported by the water very easily. Fluvial transportation is the movement of Earth's material enacted by the running water. As the particle size increases, the velocity needed to transport also increases. The material transported through the stream is called as its stream load. Processes involved in transportation. Transportation involves the following processes. Traction. It refers to the load that is rolled along the bed of the river. Saltation. It refers to the load that is bounced along the bed of the river. Suspension. It refers to the load that is transported in a river's flow or current. Solution. It refers to the load that is dissolved by a river and then transported by it. Flotation refers to the material transported on the surface of a river. Stream load. Stream load is a geologic term referring to the solid masses carried away by a stream. The amount of solid load that a stream can carry, or stream capacity, is measured in metric tons per day passing a given location. The stream capacity is dependent upon the stream's velocity, the amount of water flow, and the gradation. The stream load is composed of three components as the dissolved or solution load, the suspended load, and the bed load. Bed load is that which is moved across the bed of the channel. Bed load is transported in two ways. The first one is traction, which is a scooting and rolling of particles along the bed, and the second one is saltation, a bouncing-like movement. Saltation occurs when particles are suspended in the stream for a short distance, after which they fall to the bed, dislodging particles from the bed. Three types of loads. Water has the ability to dissolve soluble mineral substances on the surface and also within the groundwater system. The dissolved load comes primarily from groundwater seepage into the stream. Suspended load is comprised of sediment suspended and transported through the stream. Turbulent flow suspends clay and silt in the stream. Suspended load comes from material eroded from the surface bordering the channel and deposited in the stream, as well as erosion of the channel itself. The stream capacity is the maximum load of sediment a stream can carry for a given discharge. The stream capacity increases with increasing flow velocity. Turbulent flow occurs under higher velocity, thus increasing the water's ability to dislodge material from the bed or sides of the stream. Stream competence is the largest size material the stream can move under a given discharge. Erosional landforms. The erosional landforms of the running water are very wide. They are river valleys, canyons, gorges, waterfalls, potholes, ravines, gullies and rills. Canyons. A canyon or gorge is a deep ravine between pairs of escarpments or cliffs. It is most often carved from the landscape by the erosive activity of a river over geologic timescales. A canyon may refer to a rift between two mountain peaks. Rills. Rills are shallow channels eroded by threads of turbulent flow developed in the sheet flow. During rainstorms, rills erode headward on the steepest local gradient at faster rate. On open slopes, they tend to form parallel to one another, converging in hillside hollows to form dendritic patterns. Rills are ephemeral features. They may be destroyed and recreated during major storms. The rills terminate at the base of slopes and thus they are not part of the regional drainage network. Depositional landforms. The depositional landforms created by the running water are floodplains, alluvial fans, deltas. Floodplain. A floodplain is an area of land adjacent to a stream or a river course. It stretches from the banks of its channel to the base of the enclosing valley walls. This region normally experiences flooding during periods of high discharge. These are the surfaces of low relief developed on the alluvium adjacent to a stream. The floodplains become the stream bed during flood seasons. The floodplains contain various features like point bars, lateral accretion, overbank sediments, horizontal accretion, levees, levee crevices, splay deposit, meanders, neck cutoff, Oxbow lake. Features of deposition. The term alluvium is applied to all fluvial deposits with the exception of deltas. Streams carrying coarse sediments develop sand and gravel bars. These types of bars seen often in braided streams which are common in elevated areas. Bars develop in braided streams because of reductions in discharge. Two conditions often cause the reduction in discharge: reduction in the gradient of the stream and or the reduction of flow after a precipitation event or spring melting of snow and ice. Sandbars are the depositional features of a river. Point bars develop where stream flow is locally reduced because of friction and reduced water depth. In a meandering stream, point bars tend to be common on the inside of a channel bend. Rosgen's observations. Rosgen 1996 proposed the following features that are created during the course of deposition by a river along its flow path. Creation of point bars with few mid-channel bars, numerous mid-channel bars, side bars, diagonal bars, main channel branching with numerous mid-bars and islands, side bars and mid-channel bars with length exceeding 2 to 3 channel width, and delta bars. Channel features. Streams with high sediment loads that encounter a sudden reduction in flow velocity generally have a braided channel type. In a braided stream, the main channel divides into a number of smaller, interlocking or braided channels. Braided channels tend to be wide and shallow because bedload materials are often coarse, sands and gravels, and non-cohesive. Meanders. Meandering channels form where streams are flowing over a relatively flat landscape with a broad floodplain. Technically, a stream is said to be meandering when the ratio of actual channel length to the straight line distance between 2 points on the stream channel is greater than 1.5. Channels in these streams are characteristically U-shaped and actively migrate over the extensive floodplain. Floodplains develop when streams overtop their levees, spreading discharge and suspended sediments over the land surface during floods. Levees are ridges found along the sides of the stream channel composed of sand or gravel. Levees are approximately 1/2 to 4 times the channel width in diameter. Floodplain deposits can raise the elevation of the stream bed. This process is called aggradation. Oxbow lakes. Oxbow lakes are the abandoned channels created when meanders are cut off from the rest of the channel because of lateral stream erosion. Alluvial fans. An alluvial fan is a large fan-shaped deposit of sediment on which a braided stream flows over. Alluvial fans develop when streams carrying a heavy load reduce their velocity as they emerge from mountainous terrain to a nearby horizontal plane. The fan is created as braided streams shift across the surface of this feature, depositing sediment and adjusting their course. Deltas. Streams flowing into standing water normally create a delta. A delta is a body of sediment that contains numerous horizontal and vertical layers. Deltas are created when the sediment load carried by a stream is deposited because of a sudden reduction in stream velocity. The surface of most deltas is marked by small shifting channels that carry water and sediments away from the main river channel. These small channels also act to distribute the stream's sediment load over the surface of the delta. Many deltas are triangular in shape. Deposits of deltas. Most deltas contain 3 different types of deposits as foreset, topset, and bottom set beds. Foreset beds make up the main body of deltas. They are deposited at the outer edge of the delta at an angle of 5 to 25 degrees. Steeper angles develop in finer sediments. On top of the foreset beds are the nearly horizontal topset beds. These beds are of varying grain sizes and are formed from deposits of the small shifting channels found on the delta surface. In front and beneath the foreset beds are the bottom set beds. These beds are composed of fine silt and clay. Bottom set beds are formed when the finest material is carried out to sea by stream flow. Floodplain management is a promising area of study in fluvial geomorphology. It is an interesting topic in physical geology and geomorphology.